This problem right here is quite lengthy. I'm going to work through this. Take a little while to go through. I've got two of these lengthy problems, but I really like these because they touch on just about everything that you need to know to understand putting all this together. So if it requires 745 grams of calcium chloride to reach a point of saturation in a 1 liter solution at 25 Celsius, then we encounter some questions. Gram solubility, molar solubility, molarity of any ions present, solve for the KSP, and then explain the magnitude of the KSP with solubility rules. Alright, so there are several things here that we're going to do. So again, highly recommend that you consider pausing that and working through that problem. And if you're totally lost, then we'll go ahead and get it going. So we're going to start this with the gram solubility. I actually lay these questions out to kind of help it flow through in order. It's 745 grams divided by 1.00 liters is 745 grams per liter. There is, in fact, our gram solubility. Molar solubility, 745 grams per liter. From grams, I'm going to simply just convert that to moles. Keep in mind that calcium chloride, would be a good point to note the nomenclature, is CaCl2. And pretty much 111 grams to the mole. 745 divided by 111 is 6.71 moles per liter. Again, we're still talking about the molar solubility, 6.71 moles per liter. All right, then the question says, what about the molarity of any ions in this? So we're talking about CaCl2 solid going into solution to make calcium ions and 2 Cl- ions. So for the calcium ions, 1 makes 1. I get 6.71 molar for the calcium ion concentration. However, for the chloride ion, I end up with 13.4 molar chloride ion because, again, 1 CaCl2 makes 2 chloride ions. Question number 4 on there said, what is KSP? The KSP is 6.71 to the first, 13.4 to the second. And I get a KSP of 1210 for my KSP value. Explain the magnitude. That's a pretty big KSP value. That means this thing favors that side. And in terms of solubility rules, we learned that all chlorides are aqueous except lead, mercury, and silver. So that's why we learned calcium chloride is pretty aqueous. Now again, if I put 750 grams of it in a liter at 25 Celsius, 5 grams are going to precipitate. It's a saturated solution. Only 745 will go into solution. Now, I might be able to heat it up and get more to go. Might be able to get it to a point where I even heat it too high and it's unsaturated. And just to review some terms, if we cooled it back to 25 and all 750 stayed in solution, then that would make it a super saturated solution, but that's really not the point of focus for this particular question. This one's just solving through from a gram solubility to a KSP, and then answering a generic question regarding solubility rules. This is quite soluble, favors the aqueous side, product side. Alright, so I've got one more of those lengthy questions. I really like this particular question. It goes along with a lab that we occasionally do. This is actually backward from the lab. In the lab we solve for KSP using all these other things. In this one I'm going to give you the KSP and have you find all the other things. Given that the KSP for calcium hydroxide is 1.3 times 10 to the negative 6, what are the concentration of any ions present in solution? What's the pH? What is the molar solubility? What's the gram solubility? And then throw in another question that kind of goes along with what we talked about there at the end of the last one. Review topic. Describe a solution made with 0.35 grams of calcium hydroxide diluted to make a 1 liter solution. So we're kind of doing a comparison there with the last question. Again, try it on your own, pause the video, and then I'll go ahead and work through it. Alright, so in order to solve for this, again, we've got to know enough about nomenclature to be able to write the formula correctly to start, and then secondly, we've got to be able to write our equilibrium equations, 2OH minus aqueous, and I've got a KSP of 1.3 times 10 to the negative 6. Now I gave you a KSP and I've asked for ions, so that's probably a good indication that we're going to go up by x and up by 2x. So 1.3 times 10 to the negative 6 equals x to the first, 2x quantity to the second. So it is equal to 4x cubed. We've seen that number a few times. Don't think everything is 4x cubed. It's just because there's 1 and 2 that it does that. We could have other situations where we have 2 and 3 and things of that nature as well. 1.3 times 10 to the negative 6, divide by 4, take the cubic root of that, and I get that x equals 0.006, I'll go ahead and take an extra place here, 0.00688 moles per liter. Again, that's the molar solubility because 1 and 1. But question 1 says, what about the concentrations of any ions present in solution? So calcium ion is going to be 0.0069 molar. Again, that's the Ca++. And the hydroxide ion is going to be double that. Point to the right place there. Going to be double that. So 0.014 molar for the hydroxide ion concentration. Question 2 says, what is the pH? Well, we've got a hydroxide ion concentration, so negative log of 0.014. I get a pOH equal to 1.85, and I get a pH of 12.15. pH equals 12.15. So there's the pH of the solution. So, if you had this saturated solution, you put a pH meter in it and you read that, you ought to be able to work backward to get your hydroxide to plug it in to solve. Now keep in mind your pH to pOH is going to give your total OH. So in order to get your X, your X is going to be half of that because the total OH is going to be twice as much as the calcium ion concentration. So if you're working backward through it, keep that in mind with regard to pH. Again, kind of going along with the one, if we make this basic, it's going to shift it this way. It's going to be less soluble. If we make it acidic, effectively removing hydroxide, then that would drive this to the right. We could also add in a sulfate to bind up the calcium, and that would also shift this to the right. All right, question 3, what is the molar solubility? Well, since X is 1 and 1, my molar solubility is, I'm going to report that now, 6.9 times 10 to the negative 3 moles per liter. Again, just same as X. And then it wants me to take that to the gram solubility. 0.00688 moles per liter. 1 mole is, I believe, about 74 grams. And I get 0.509 grams per liter. So if you had a whole liter of this saturated solution, maybe you made it by adding calcium hydroxide, and until you add precipitant, you filtered it off so the precipitant could be separated out, and then maybe you evaporated a whole liter of this to dryness, you should have about 0.504 grams. Now again, you're probably not going to do that with a liter, but you could also do that with a small quantity, 5 milliliters. And if you know how many grams are present in 5 milliliters, then you could go from that to how many grams per liter, and you could work backward again through that problem. So again, I'm taking you one way, but I'm just pointing out that you don't always have to work these in the same direction. You just have to start with what you're given and then be able to work to your unknown. Alright, so this last question says, what about 0.35 grams of this? We just found that there should be 0.504 grams in a liter container, so 0.35 grams would be an unsaturated solution in question number 5.